live right now, but I have no idea if it's true. So let me check on YouTube. Um, okay, just a second. Okay, we are online. Great. Hi, Renato.
Ciao. Hi.
You want to talk in Italian?
I think talking Italian is probably not the best idea right now, but
Yeah,
maybe I
maybe
should.
not. Someone could not understand, probably. Anyway, do you want to introduce yourself and say who you are?
Sure. I try not to steal too much time about it. I'm
That's
Renato.
okay.
I'm Italian, as we just probably have guessed from the name and from what you just said. And I work as a principal cloud architect for Funambol, and I mainly work most of my time dealing with stuff on AWS, trying to reduce costs whenever possible, and play a lot with mainly storage, relational databases, and whatever else you might have to run on cloud provider, public cloud provider.
Great. So actually, this leads to the topic, because some time ago you published a nice post on LinkedIn where basically you were saying, why do companies start big projects to reduce the costs of cloud computing, and then they obtain just very small benefits from these projects? And so my question, and I agree, but my question for you is, okay, then what keeps the costs high, and what can we do about it?
Right. I think the post you mentioned was mainly related to how to migrate data. So yes, of course, when you want to cut your cost on a cloud provider, you have basically two options. Try to optimize what you have, both in terms of small optimization that maybe you can have as low-hanging fruits, because maybe you're using something that is over-provisioned, or maybe because you're using some service that you really don't need, or maybe there are things you can improve in your product, or do small changes in your product that, or fix bugs in your product that give you some cost optimization. So think about your case when you think about relational databases. Maybe it's just the problem is more your product and the queries you have on your application layer than really the cloud provider itself. And of course, the other approach you can have is say, okay, I'm using cloud provider A. I want to go to cloud provider provider B or provider C, because I saw an amazing advertisement that said that's much cheaper, is 4 times cheaper, 10 times cheaper, whatever else. Usually the truth, there's not a straightforward solution usually. I mean, that's at least my feeling, is that I don't believe for a second there's any provider that offer you the same service with the same capability for half the price. I mean, you that's life. So usually there's a catch somewhere, and usually the project where you're expecting to save 100, you're probably in best case are going to save 10. But that's and you have to factor as well the cost of all these solutions. So try to find low-hanging fruit or do product optimization. You might see the benefit long term. Migrate to a different provider can be an option, but as well, you have to remember that maybe you're not going to see the full benefit you wanted to have, and maybe you're just trying to hack a bit the system. And of course, I'm not in favor of every cost reduction. I mean, of course, you cannot cut corners. That's at least my feeling. You need to find where you can optimize. I'm talking about optimization, not try to spend nothing. But that's...
Yeah, because of course sometimes you pay for a very good reason. So.
Yeah.
But one could object, okay, it's true that surely there is not a provider which asks you half of Amazon and provides you the same service. But is it possible that maybe for my particular case, I will save a lot if I switch to something else?
Absolutely. I actually think that there are many providers offer cheaper solution or offer a solution that are more tailored for your scenario. It's just that in general, I think that you should... there are two aspects. One is unfortunately, the kind of vendor lock-in that is not just technical, because we tend to focus a lot about the technical aspect. So we tend to think, oh, I'm not going to use provider A for that specific service because that will mean I'm thinking about Amazon. I'm not going to use DynamoDB because, well, that's a solution that is proprietary from the provider, and I don't want to have to be locked to them. Reality is often you're locked to a provider, not just by the specific solution, but as well by the effort you need to have to move from provider A to provider B and the cost associated to it. So when you need to migrate, not surprisingly, most of the large cloud provider offer you data take-in for free. So you can upload data to S3, you can migrate data to Amazon or to Google for free. So data transfer is free for going in. And of course, you pay when you go out. So, the idea is, the concept is more like a mortgage. It's like your data is the collateral. One day you want your data back. The day you want your data back, you pay to take your data out. Of course, they encourage you to move in, and that's going to be free. And moving data is not as cheap usually as you might think. That's part of the problem. As well, sometimes even for simple thing is, I'm thinking about, for example, a managed database. Usually, if you play with a managed database like RDS or Aurora or whatever, you think you do that for a reason. Usually because you're not good enough, or you don't want the complexity, you don't have a database administration. You want to offload part, at least, of the effort to the provider. Yes, you can migrate to a different provider, but to do that, you need the knowledge to move to that provider. I mean, yes, the Amazon of this world can tell you, yes, you can easily migrate MySQL out of Amazon. You can just do a read replica. You can do it on your virtual machine. You can do it in a different cloud provider. Okay, let's think for a second. You don't even have cost associated with data transfer. Let's say that we are in ideas. You still need to know how to set it up. You need to know how to promote that replica then to the new master. Of course, if it's a pet project with just little data, it's not a big deal. But if you're managing a large production database, before you really take that risk, before you're really confident in doing that, well, it's quite a learning curve. I mean, usually the attrition to stay where you are is higher than the risk you put together. So I see that as well a vendor lock-in in some way. Even if it's technically is not, technically they can tell you and they sell you the idea that you can move out. Moving out is really much harder than moving in.
Oh, yeah. Well, of course, it's in their interest. Okay, but before I ask this question, you already mentioned that part of the problem could be missing optimizations like slow queries and stuff like that. So I suppose you say that because in your experience, it's the main point?
I would say it's one of the main points. I mean, if I think at least for a database, I can think 2-3 reasons that you might get it wrong. One is defaults. I mean, yes, defaults are great. Amazon as well is trying to make your life easier, up to even a bit too much now, in the sense that compared to the past as well, if you use the user interface, you might end up in choice like, oh, is this database a production database? And you immediately say yes, because that's going to be a product. And of course, you have some default, like, I don't know, provision IOPS and things like that make sense maybe, but it makes sense. Of course, are better. I mean, of course, a provision IOPS for a storage is better than a standard IOPS. But you should see some of your metrics, because moving back is not going to be straightforward. Any copy you make of that database is going to have the same provision IOPS. So maybe you're going to end up with your staging database, your dev database, or your night database that you use for just testing purposes with the same high cost. So it might make sense. I mean, by default, as idea is, yes, it's great, that concept, but it might be not ideal, or that by default, when you say that it's a production, they're not going to tell you to use a very small instance. But production can mean very different thing to many different people. I mean, you might have one production that is really big, where you really need a lot of sharding, a lot of different database. And you might have a site that is production that needs 24/7, but doesn't mean that it needs a large deployment. You might be able to do it with little. But yes, I agree with you that most of the saving come from a poor running query, wrong, something you forgot from the past, an index that is missing, a table that has been adding or removing record for the last 4 years, and suddenly that table is huge. And if you do an optimize, you suddenly realize that it could be a quarter of the size that it was. And of course, the auto-scaling of your storage is great. It's a great feature because you don't have downtime. At the same time, that storage keeps growing because you don't do any maintenance. one day you realize it, but it's not that it's going to shrink. I mean, the amazing thing, the cool thing of EBS volume or any storage, actually on Google is the same. Actually, it's very easy to get a growing storage. And that's cool thing because you don't have to take care of it yourself. Yeah. But how easy is to make it smaller if you need? Do you need? Yes, you can dump your database, create a new one. How many people are really doing that? No one.
No one.
So yeah, so as well, those extra indexes that maybe you have put just by chance that you don't need, and they're just making your write worst, are still a problem, and it's going to be hard to roll back. But the most common problem to me is on a database, the easiest way is sometimes, I mean, you can do a lot of optimization on the hardware, on the configuration or whatever, but usually when you reach that point means that you should already have addressed all the other issues. So it means that whatever you use Percona monitoring tool, whether you use Performance Insight from Amazon or whatever you use your own tools, you should have at least make sure that first you don't have crazy query running that are taking most of your resources, because you can make it your database amazing. I mean, it's amazing, for example, that they offer service like Aurora Serverless, where it scales automatically, and you say, okay, according to the number of connection or the CPU, your database can scale up and down. You can set your own limit, and it's great because you can keep your uptime. Amazing. Yeah. But, it's a big but. That means that if you introduce a bug, either that you leave the connection open or that a query is badly performing, yes, you might gain time, but that means that your database keeps scaling to address that bug. So you might not see immediately the effect of your bug. You might see that your cloud system is helping you, but the limit becomes your credit card, basically. Is where maybe the fix is a bit more upfront. So it's
yes. So the basic problem is probably, okay, the cloud helps you to tolerate any kind of non-optimized stuff you may do, any kind of performance bugs, and then yes, it does, but you spend a lot and you don't realize you are doing something probably wrong.
That's part, I think, of elasticity. The problem of elasticity is it helps you a lot, but at the same time, if you don't keep an eye on it, it might make things not worse, but it might make things incredibly expensive. And that day you're going to say, oh, maybe I want to change cloud provider. Well, that's not going to help. Or maybe it helps, but the problem is that maybe the first problem is upfront. You're trying to address the problem the wrong way around. So that's a...
Yeah. But then I have a question for you. Suppose a company says, okay, we are actually paying a bit too much, but probably it's simply because, we have a lot of users. So what is an indicator that you are actually paying a lot because the application is not optimized?
A good analysis done by someone who understands your database, I guess. I mean, there's no way around. I mean, there's no magic bullet done by automatically. I mean, some you can catch them yourself in a kind of automatic way. Some you have to understand how the system works, because, I mean, it's great if you say, for example, I want to have a database that scales automatically. I want to use Aurora Serverless or Microsoft, the same concept, but. And then you suddenly decide to have some running queries that run for hours because they need to collect some data. That's perfect. It's a use case. But either you have a database that scales elasticity in an elastic way without dropping queries, or you have long-running queries. You cannot have the best of both worlds. I mean, either you have a database that is there for you standing and up and running where you can run your queries, or you don't have it, or you have that you're paying for elasticity that you're not going to use because your database cannot scale because you have some long-running process on that database. So that's, to me, the most challenging part. I think one of the challenges as well, we tend to assume that you can live without a database administrator because you are running on the cloud. And I think it's simply the point is that you have moved the task of the database administrator Certain tasks, of course, are smaller, as you know, on the cloud. I mean, it's like, of course, if you're running Aurora, you're not going to manage yourself the operating system. But there are other parts that are still there and need to be understood to be able to run efficiently your database. That's the feeling I have.
Yes, and honestly, Aurora has a lot of downsides that a lot of people don't know, in my opinion.
You mean that you don't believe the thing that is 5 times faster than... I'm kidding.
Oh, no. Not only that, it could actually be slower, and it's not uncommon. Especially if you have many indexes and a write-intensive workload. Anyway...
that's quite actually common. I mean, we always find a proper common scenario where things are better, but I think that's part of life. We tend to kind of show the scenario where our setup works best, but it's not always the only scenario you can think of. So fair enough.
Of course.
But as well, thinking about a database, when you mention about cost, one of the things that, for example, Amazon does is, okay, you have cool things like backups, automatic backups. You can say, okay, I keep my data for, I don't know, I want to have automatic backup for 1 week, 30 days, whatever, up to, I think, 35 days. I can't remember the current maximum limit. But you think, why should I not want it? I mean, it's great. It's there. I just have to flag and decide how many days.
Yeah.
And they even tell you, oh, that's usually basically free for everyone because we allocate free storage as much as storage you use. And as we just back up in an incremental way, most of our users don't experience any cost. Well, that's most, not everyone. And if you have a very write-intensive database, those costs can be significantly higher. I mean, I saw deployment where it actually costs more than real storage. So the fact that you have things out of the box with a flag, it's amazing, it's great, but at the same time, you have to understand what they do behind the scene. And yes, they hide the complexity for you until the moment you need to figure out what's really happening to go around that complexity and cut your cost. Because if you don't really understand what a backup is on the database, then, well, it's pretty hard to do any optimization apart from just reducing the number of... I mean, of course, the quick fix, you can say, okay, well, then I keep the backup for less days. That's not an optimization. That's just saying, well, I'm just reducing my ability to recover from mistakes. That's something else. But maybe you have behind 2, 3, 4 tables that behave badly, or where you're writing data in the proper way, or where maybe the is just doing a partitioning of one of that table could help, because maybe then they are the separate file and the backup is smaller. It can be different things. You can try different things. And maybe the cloud helps you in testing those things, because, I mean, spinning, you don't have anymore the problem to say, oh, I need a new setup to try it. I mean, you can try it. I mean, that's the cool part. But you need to understand what's happening, and you need the help of someone to understand what's happening. It's not that everyone can do it. That's at least the feeling I have.
Yes, I agree. I was hoping that someone would ask questions in the chat, or maybe, even say, no, you're wrong, because that would be great, because we could discuss with different people.
Absolutely.
But it's not happening, so I will ask you something else myself.
Sure. Now, actually, I have a question for you, Bahis.
Oh, okay, please.
What do you find is usually on cloud deployment, in terms of, almost in your case, databases, the thing that people usually get wrong? If you have to say the major mistake that people do.
The major?
Can be as well a small one, but a very common one.
Well, there is a very basic thing, which is what you said. Switch to the cloud because they think they will not need a DBA, particularly with RDS. And then actually often they don't even monitor what's happening in their instances. And that's because actually they don't have a DBA, so they don't know which metrics to watch and what to do about it. And that doesn't even allow them to find out that they are having unoptimized stuff and they're wasting money. so most of the times they will just assume that, okay, the database part must be healthy because we're using RDS. There could be a problem because we have too many users, so let's just add instances. But actually, that's the second biggest mistake, in my opinion, thinking that if you have performance problems, you can just add one more instance. But that's not the case, because if you have a slow query, if you have two instances, it will be slow on both instances. Because the problem is not that you don't have enough CPU time or something like that. The problem is that your query reads too many data to return results.
So you mean it's not going to scale anyway in the long term, even if I'm sharding? Yeah. The thing I don't like about sharding is that,
No, I mean, things scale if they are designed to scale. But if you just add an instance, you cannot assume that it will magically scale. Because, again, there could be different problems. A possible problem is that you're running too many queries, and then it makes sense to have one more instance. But it doesn't make sense at all if you have a query that is slow because it doesn't use indexes. Because even if you run it on a query that is not doing anything, it will still be slow.
I get what you mean. Yes. Yeah, that makes quite... Well, I think as well that the horizontal kind of approach that is really cool, that you could do in the cloud of sharding and whatever your data. Yeah, I mean, it makes sense to shard when you need, but the same problem is that going back from sharding is quite painful in the cloud as well. I mean, if you have 2 different RDS or 4 different or 8 different RDS, and you suddenly want to go back to 6, it's not that straightforward. There's any way to go back. So yeah, there's a pain point to do it. And as well, when you think about automatic backup and all the features or even all the metrics exposed by them to analytics or whatever, then they are by database, by RDS, by instance. They're not as a shard, it's not a class, it's not nothing. So if you want to do a restore to point in time at 3 a.m. of our class, you have different database than to manage. So yes, it's valuable, there's value there, but the maintenance point is not anymore something that is just a one-click thing. It starts to become much more normal deployment, I will call it.
And even if you think about a solution like sharding, you should keep in mind that it's always a trade-off, right? Because you gain something in one direction and you will probably lose something in another direction. Okay. So in the case of sharding, you will need to implement probably the logic that decides where a certain row should be located.
Absolutely.
Even if you don't do it in the application, even if you have some kind of middleware that does it, well, you will still have to configure it properly. And if it doesn't work properly, actually, it could be a big problem.
No, that's probably true. I would say that to me is so okay. Yeah, that makes quite sense. I was thinking as well in terms of write IOPS, read IOPS as well. There's an extra layer there that then is according to the database you're running, and it might be as well the sharding doesn't help you too much in that sense. But yeah, that's you hit a certain point, some limits.
But even if you have a cluster of databases and it will help to scale reads for sure, because you can read from any node of the cluster. But every time you write to a node, the write must be propagated to the other nodes. So
if it's an order,
so writes don't scale. I mean, I'm not saying this is a bad idea. It depends, but you have to keep in mind what you gain and what you lose.
Absolutely, yeah. Yeah, no, I'm thinking as well. And then, of course, I mean, it's not just databases. I mean, data optimization, you can do them in any layer. But I mean, yes, I mean, if I have to think, I mean, the one that I usually find quite interesting is things like storage optimization on the database or things like that I find really quite challenging. Because as well, it's pretty hard to decide upfront what people need. I mean, if you think about Aurora that you don't like or whatever else. It's like one of the cool point they tell you is, okay, you pay just for the storage you use versus the storage you allocate. But what's the real trade-off? I mean, okay, you pay more, so then you have to decide how much storage free you have on compare on a normal RDS. So in RDS, maybe you have allocated 1 tera and you use just 600 gigabytes. And so you think I'm wasting the rest. But actually, it depends, because maybe you're not even using provision IOPS. You decide to go because it's more than enough for you. The standard IOPS you get from a normal, let's call it storage. And then that number of IOPS grows linearly with this allocated storage. So if you have 1 terabyte, you have probably, 3,000, or now I think it's 3 multiplied by the number of gigabyte, whatever. It gets really hard to optimize the cost, because you're doing the standard assumption you make, the simple one might not be your case. It's easy to say, yes, you always need provision IOPS. Well, maybe you don't always need provision IOPS, because yes, it's guaranteed, the percentage is guaranteed at a higher level, but if your database actually has really a lot of storage and really little activity, because maybe you have an elastic caching for whatever, maybe actually you don't need it. And the ratio of cost between the standard storage and the provision one is significantly more expensive. Of course, it's better. I mean, there are many things you can get better. Of course, you can get a bigger instance. You can get a better, you can use a metal instance. You can do many things. You can always allocate more. The problem is when is just better and when it's just over provisioning, when the latency that you're going to gain is irrelevant for your use case. So
that's absolutely.
That's the key aspect for me. But I think at the end, the monitoring the cost is the easiest way to kind of really and start from there, and then go back and see what you really do right and wrong at the product level. But I think the key part that I think you mentioned before is you need to kind of forecast upfront how much you expect to spend for a specific scenario in the database. Because otherwise you're just ending up saying that you're not going to accept that your product is not performing as well as it should. You're just saying, oh, well, databases are expensive. I should get out of relational database because they're expensive. And it's normal to spend a few €1,000 more on that part. And maybe it's not true. Maybe it's just a couple of bugs that you can fix and you can save a lot of money there. That's
yes, and it can also be that, okay, you can find maybe NoSQL databases that will be faster for your case, maybe. But in that case, ask yourself why they're faster. Maybe they offer less guarantees on the writes, which could be okay for you. In that case,
depends on the use case. Yes, absolutely. But that's one of the examples that I found to me quite bizarre was in terms of databases, like the trade-off between what you can on a managed database configure yourself and not configure yourself. Because, for example, if you want, of course, ACID compliant database is always better in theory. In theory, I love it. But if I can change that bloody properties from 0 to 1 to 2 and decide that maybe the trade-off for me is good enough, and well, maybe I can write more and with the same resources, and that's a cost optimization as well. If my use case allowed to, maybe for me 1 second of transaction lost in that particular database is acceptable, because maybe in that database I'm not storing anything that really require ACID compliance. So that's really depends on the use case. And it's important to understand when you play with different provider, what that specific provider is supporting and what is not supporting. Because if a property, you cannot change it, or a configuration you cannot optimize for use case, well, maybe they can claim that they are 12% faster than Cloud A is 12% faster than Cloud B. But if I cannot change what I need to change on Cloud A, maybe at the end for my use case is lower. So it's the number of things you have to consider might be higher than what you would have hoped. That's the feeling I have often. But
absolutely. I just want to tell you that I see Emerson wrote in the chat. He wrote, well, not always Aurora would be the answer for your services. Yeah, I think we
Absolutely.
agreed on that already. And he says also their cost is very pricey for what they deliver. Yeah, it's absolutely true.
I think one of the challenges as well, if I have to say, to add on that, I will even say that sometimes it's pretty hard to understand. That's, I mean, the good thing about Amazon is all narrowed down to 10 different components. That's cool.
Yeah.
And that's cool in one sense. On the other sense, it's pretty hard to get the full picture because you tend to think about just the CPU and the storage, but maybe there are a few more components, whatever the storage provision, whatever is like how you calculate the number of requests. It might be not always straightforward. It's not simply a count or a number that everyone has in mind up front when you think about a scenario. Yeah. And the same for many, or like, I don't know, you can have an enhanced matrix that is cool, but I know it's not going to be crazily expensive, but how much is going to cost me? Well, I have to do a few multiplication, and that's not always that easy. And I think that's a fair point as well.
And Emerson also wrote that they recently migrated from Aurora to MariaDB RDS. He says we, and I'm very curious if he can say who is we. But if he can't, it's okay. And then he says, MariaDB RDS is performing way better than Aurora, so Aurora is really not always the best option.
Cool to know, really good to know. But I assume again, it depends on the use case.
Yeah, it depends. I mean, RDS also takes some decisions for you, just like any other offer by cloud providers. So it could be the right choice for many cases, but not necessarily for you. And also, well, there is something I don't really like about RDS. Like, for example, it's managed in a totally non-standard way because you're not root and you have to use their strange concepts of, parameters groups.
Yes, to modify and you have less control. Yeah.
You can get used to it, but again, it's a sort of cultural lock-in because they force you to work in a totally non-standard way.
That one I tend to agree in the sense as well. That's what you mentioned before in terms as well of what is really a vendor lock-in. It's not vendor lock-in because you can move it out, but you have to remember that if you go in that direction and if you're used to the concept that, I think the great point of something like RDS, but as well is the concept for most people, I think that's why as well as being so successful in 10 years is, okay, I don't have to manage myself as slave. Failover or whatever. They do it for me. Most people have no idea what that is, and that's cool.
Yes, you use availability zones. I mean, yes, it is cool thing. But I don't deny it.
But you then need to understand as well what the implications are, what you can do and what you cannot do, or things that if you understand as well a bit it's the standard trade-off between one side you want to know what's happening. You shouldn't know. If you use a managed service, you don't want to know what's happening behind the hook. You want to see it as a black box because you say, okay, I'm paying for a managed service. It's their problem. I don't want to know it. At the same time, you have to understand how it works to make some conscious decision. Because do I need multi-AZ or I don't need it, multi-AZ or whatever? Well, it's not just a matter to use a multiple zone, but as well, if you do a backup, automatic backup or whatever, of course, the way it works, it does it on the passive slave, so the passive master, so he locks just that one. If you have just one node running, of course, he blocks writing for all the time it takes to make the backup. It might be obvious to someone who knows how a backup works and why it has to be like that, but it might not be that obvious to someone that is just using a interface to start a database because he thinks, oh, well, whatever. I'm just making my choice according to if I really need the uptime or not. But it's not just about the uptime. It's not just about, it's as well that there are other features that depend to be more than one node. So there are a few things that are, and I think that's one side he helps people to set up a database or feature or whatever and optimize them in a way that is easier than running it yourself. But at the same time, there's a price point there as well. Because, of course, the component, if you look at, there was a few articles on the topic, different topic about the cost of RDS versus the running it yourself. That, of course, it will be a never-ending topic because you have to consider all the aspects of the thing. But, of course, the cost of the instance price is going down, of course, in the years, even more and more. So the percentage cost of the managed service is always higher because it's life, it's factor of life. And you have to accept if that's okay for you or if actually you can do better than that. But if you can do better than that means that, of course, if a person is good enough as a good database administrator, knows how to manage the database, want to do RAID or whatever else, of course, you don't go that way. But that's something else.
Absolutely. Yes. Okay, I think we're keeping this talk too long if we continue. But before saying bye, I want to ask you something.
Sure.
Okay, we focused on databases. But I have a doubt if it's just because I work on databases or because actually you think it's the main point.
Well, it really depends on the use case. If you have I think one of the problems when you think about your cloud bill is that you receive a nice bill from AWS, a nice PDF that you go through it, and it's not that they are ordered by cost, they are ordered by name of the service, and you might have some insignificant number down there. You need to make sure that you focus on what's big for you. If you have a application that is very intensive on data storage, whatever is relational database or whatever is object storage or whatever else, most likely your optimization should be in that area. And you can go very deep in that sense. You can find really then, there's nothing weird there is, but usually that's where most of the saving can be done. Why I think it really depends on the use case, but at the same time, I tend to have the feeling that the standard suggestion you receive to make cost optimization on the cloud I'm not saying they're wrong, but they're always like, use Kubernetes, use auto-scaling group, is always focused on how to minimize cost on the EC2 on the compute power. That is cool, but try to remember that there are other pieces down there as well to optimize. Then it really depends on the use case. Of course, if your bill is 90% EC2, maybe you should think there before looking at something else. But I would say on a personal level, I would find that it's mainly really on the storage and databases where you can really work a lot. Or really see major. To me, it's really a place where a bug can really badly affect as user. Database can be a bottleneck, so a badly performed query can really kill. But you can say the same for API, but yes.
No, you definitely can, but I believe that it's most common that databases are the bottleneck because, well, first of all, they are very complex technologies that do a lot of stuff, and you have a lot of requirements for your databases. You don't usually think about it, but you are actually asking them a lot, and it's not uncommon that they don't keep up. And also another problem is probably cultural, because developers know code, obviously, but they don't know databases in most cases.
That's probably a fair point.
Of course, it's not true for everyone. There are some developers who are absolutely passionate about databases and know probably as much as me. But there are also a lot of, probably the majority of high-level developers, they don't really understand why an index could make a query could make a query fast, and therefore they don't know how to build a proper index and the proper query.
Yes, that's probably as well, because usually there's always a trade-off as well in any index or any change you make. So it's sometimes harder to decide that maybe something that you need in production is not really straightforward when you see it in a smaller deployment, that maybe on an application layer instead is much easier to see. So in terms of cost saving as well, you can do much more there. But that's...
Yeah. I think there's also something that companies could do better, because if you think about it, when a developer makes a change, what does he do? Well, he makes the change locally, he tests on his local machine, it works, it's not slow because it cannot be slow on his local machine.
Because usually there's no data, and if there's data, it's fake data with really a set that is kind of done.
Of course. And there aren't other users connected. So how could it be slow in most cases? But then everyone thinks that the change is okay and it goes to production. And then probably it's not really okay, because once you run it on a server which is working and which is already well loaded, well, it will be it could be slow because queries will have to read more data, will have to run concurrently. Yeah.
I think one thing to close that I find really interesting in the cloud approach is that you can really give the price to an index. I mean, if you think about writing a bug or say, okay, that's important. You don't even have to say just, oh, that's critical, that's major, you can really give a price to any change you need to fix. Because like you're saying, I'm simplifying here, but let's say you have an index that you're saying that we need, or that a change in a query that need to be done. You can really say, look, that's the impact of that on our production that had to scale up. So we were able to contain it due to elasticity of our system. But that cost us, looking at the cost explorer in case of Amazon, but the same for any cloud provider, is costing us, I don't know, I'm throwing a number, $77 more every day. So is that acceptable to wait for, because maybe you have more important feature to release? You can make a choice, but it's quite a well-informed choice. You know the very, very real cost of your bug. That is I find it quite interesting, because it's not really just simply saying, oh, that's important, that has to be fixed, because otherwise we cannot scale. You can really put a price, basically. That I find.
Yeah, I agree. There's another question from Emerson. He says, I have a question for you guys. How can you tackle costs related to databases in AWS? EC2 would the answer, or there's other options that not everyone knows?
If you want to stay on managed service like RDS, well, the most obvious are quite well known, but it's like, of course, you can think of, okay, I'm going with really, at least my side, and I don't know if okay, you have an option, of course, to buy reserve capacity, but reserve capacity goes by class. So you need to remember that you need to make at least a choice on which database class you need before committing to 1 year or 3 years of a purchase, because you don't even pay in advance. You can as well postpone the payment, but you still commit to pay. So it's kind of it's quite a choice. This one is not a technical choice. It's just a business choice. I mentioned before, you might, in some cases, decide that you don't need provision IOPS in production. Maybe you're able to cut on that one. That's for not production database, you can schedule stop and start and whatever, according to what you need. That's another one is if you have use cases that don't need to run on the same databases, you can, like I'm thinking about if you're running some reporting or whatever, that maybe you need to provision a database for that peak, because you need to hold the user plus that reporting, and with index optimized for that, maybe you are able to spin out a different instance when you need it, and then just kill it when you don't need it. So it's kind of more elastic, and you're able maybe to scale down. But then apart from that, there's no much. You can go down to the optimization of your database, say that it's not ACID anymore because you don't need a transaction, a commit, or whatever, you can change it. But that's...
Yeah, no, I agree. I mean, if you need to reduce the costs first,
reduce the load. Reduce the load.
Well, not necessarily possible, but I ask someone to make an analysis of
That's
your
probably
database.
yes.
Check if
I will
it can
say
be
again,
optimized, and and
if I have
then
to
you can.
bet is the database layer, is the application layer. Only
Yeah.
I will say that any other improvement is when you have discarded bugs on your code, because that's the easiest. That's the one where you usually get the most benefit if you fix it.
Yeah.
Because all the rest is low. I mean, low hanging fruit somehow is not that straightforward to fix. And
Yeah. And then once things are reasonably optimized, you can do what Renato just suggested. But yeah, there is no magic answer that is valid for everyone. Unfortunately. Or fortunately, because this means that people need to pay us. Let's be honest, come on.
With that on the end, that's part of the. We are not yet in a fully automated environment where they don't need development, where they don't need a database administrator, where they don't need anyone, and they can run. Okay, that's a fair point as well. Yes,
we are very far from that, fortunately. So anyway, I think. Wow, it's 45 minutes.
Yes.
We're
running behind. Yeah.
Yeah. We talked much more than planned, but it's been interesting. So I would say, first of all, well, thank you for this pleasant
Thank you
chat.
for the chat. It was quite.
Thanks, Emerson, who is the only one who interacted with us. I hope to maybe make another chat with you in the future, and maybe we can focus on something more specific, like a single cloud provider.
Yes, absolutely.
Okay, great.
All right.
Don't disconnect because I want to talk to you, but
okay,
let's say bye, and then let's
bye, everyone.
Okay.
Okay.
Bye, everyone.